if we can all be serious about what is being discussed here. And at the very outset, I always thank my students who have helped me to put together this presentation. So these are my um, graduate students who worked on this project and helped me um, to put together this presentation. So before I get into the technical details of my presentation, so I just want to mention where I am from. I'm from Chicago. This is the map of US. I hope many of you have visited US. And next time you come to US, you are more than welcome to visit my place, Chicago. And Chicago is a beautiful place. And a lot of civil infrastructure and a lot of sustainable environmental practices that you can see. And the bottom two pictures are my university picture. It's very close to downtown, where all the activity goes on, maybe about 10 minutes walking distance. So again, I just want to give you background to what kind of research I do. I am heading these two labs, Sustainable Engineering Research Lab and Geotechnical and Geoenvironmental Engineering Lab. And a lot of my research is on geoenvironmental engineering. The first one that deals with is the environmental remediation of soils, sediments, groundwater, and stormwater. So I deal with how do you clean up contaminated soils, sediments, groundwater, and stormwater using different technologies. I also deal with waste management and landfill engineering, beneficial use of waste materials, biological degradation of the waste, landfills. So those things I also do research on. So for last several years, I've been working on life cycle assessment and sustainable and resilient engineering. This is a very broad field. I also teach a graduate level class on sustainable engineering, and the students from all engineering disciplines actually take this course. But my focus is on, developing sustainability analytics, quantifying the sustainability. And once you have that kind of framework, you can apply to any kind of engineering project. So, since I do research in geotechnical and geoenvironmental, I apply to, those systems extensively. But as you see, from today's presentation, it can be applied to, any other civil engineering systems. My master's and PhD were in geotechnical engineering, and my undergraduate is in civil engineering. So even though I teach geotechnical engineering courses and do consulting in geotechnical engineering courses, a lot of my focus is on this geoenvironmental engineering, the first and the second topic, and life cycle assessment and sustainable engineering is a emerging topic, and I've been doing a lot of work in that area. So whatever work we have done for so many years has been summarized in 4 books and many journal papers, many conference papers. If you are ever interested in knowing more details about my research, so you can go to this website and get the details. So in my research, I always say that the research is not aimed at publishing papers, but solving the real world problem. So we identify a real world problem, try to come up with a solution idea, and then we test that one in bench scale testing, large scale lab testing, and then we do the modeling and design the scale up systems. And then in the field, we go there and try to see if it works in the field scenario. If it works, then we develop the design guidelines, and design professionals can use that solution. So all our research is aimed at advancing the fundamentals, because we are in the university. So our goal is to advance the science and engineering, but ultimately to solve the real world societal problems. So in all the projects that I do, I try to consider these aspects. I do a lot of experimental research. So this is my lab. This is my equipment. So we have a lot of material testing equipment, and I do more on not only mechanical side but chemical side. So I have geochemical testing equipment, uh, and we can create the bench scale models to do whatever we want for our projects. So that's the things that we have. Um, and in terms of the students, we get students from all over the world. I'm showing the pictures of the students and scholars that I had an opportunity to work with. As you see, many people enjoy working in my lab. Nobody is crying. Nobody has a serious faces. So many of them are smiling. So it's a rewarding experience to work with students and get research done. Um, so with that brief introduction to my background, let's get to the presentation. So in my presentation, as I mentioned, this presentation is tailored based on the program theme and titles that are topics that are aimed to be covered. So I'm going to give you brief background about project. And this project involved pavement design alternatives. I'm going to mention that one, but most of the time I would say spend is on sustainability assessment. And so I'm going to apply this methodology where we look at environmental sustainability, economic sustainability, social sustainability, and we integrate all those three aspects, environmental, economic, and social, and look at, holistically, what is the sustainability. So I'm going to apply this framework that we developed for this example, but the takeaway would be you can apply the same framework for any other problem that you are dealing with. So I really want this presentation to be useful. So even though I am covering one payment example here, but it can be applied to any other projects. So then I will draw some conclusion and closing remarks at the end. So let's talk about a project that we were interested in working on. And this is regarding the payments. As you may or may not know, United States has 2.7 million miles of paved roads and highways. It's a pretty extensive network of highways. And they require huge amounts of different material mixtures consisting of aggregate, concrete, and asphalt. And a lot of infrastructure that we have, all these roads and highways, they were built long time ago. And recently, American Society of Civil Engineers came up with the infrastructure grades, and they found out that all this infrastructure needs to be, rebuilt because it has been aged and it's not working as efficiently as it should. So that, as you may have heard in the news, that U.S. Congress has passed a new infrastructure bill. Now, there are a lot of these projects are going to happen, and we going into the future, we should not be doing the same things that we did it in the past, right? I mean, so whatever the infrastructure that we're going to build, that's going to last, 50 years, 80 years, 100, next 100 years. So we really need to be careful in terms of selecting the materials and how do we construct them. And the big picture that we need to keep in our mind while doing this infrastructure is to reduce the negative environmental, social, and economic impacts and promote the sustainable development, exactly like the focus of this course. So out of this, highways and infrastructure in general, how do we know whether we are doing something in a sustainable manner or not, right? So we really need to have a quantitative framework to assess the sustainability. So, dealing with highways, so we want to have sustainable roads and highways and sustainable payments, but how can we have that, right? That's the question that everybody is asking. Now, one of the things that whole construction industry is focusing is on recycled materials. Um, so one of those materials is recycled aggregate. So remember, as I mentioned, we have this very large network of highways that are constructed of concrete. So if you are going to build, new roadways along the same paths, so you need to, break up the concrete and then construct again, right? So when you break up the concrete, common thing is to break it up and send it to construction demolition landfill. But that is not a sustainable way to do it. So what the focus now is to, use that, crush the concrete and then use it as an aggregate for the new pavement that you are building. And among many uses for recycled aggregate, roads using it as road base material is becoming more common. So there has been a lot of research that's done on recycled aggregate, and a lot of agencies have standard specifications. So this is not new. I mean, there has been, applications of this material in real practice. So, my focus is on that one, applying that one on roadway construction. So the question is, how sustainable it is. Why don't we use virgin materials rather than these recycled materials? So we did this project to assess that aspect. So there's a highway. They constructed pavement using this recycled aggregate. And we have those constructed details of the project. And then we are assessing, is that sustainable compared to, looking at these other two potential alternatives that could have been possible. So the constructed design was concrete pavement with recycled aggregate subbase. That's the how the roadway is constructed. But then we are asking these questions. Okay, that was constructed that time. It was not long ago, a few years ago, but was it a good choice? How sustainable this is. So we wanted to look at other case. Okay, if we used virgin aggregate instead of recycled aggregate, how much is the sustainable benefit is? What are the benefits in terms of the sustainability? And then other thing that we looked at is, okay, instead of concrete pavement, if I use the asphalt pavement and I use this recycled aggregate, what difference it makes from the sustainability point of view. So I hope you understand what my project is all about. So, there is a roadway and it's constructed with concrete pavement. We're using recycled aggregate, as I mentioned before. What the recycled aggregate is basically, old concrete pavement is, taken out and then crushed, and then you create aggregate, and then you're using that aggregate for the new roadway construction. So we are assessing in these three options, which one is more sustainable. So, I can say this is more sustainable, or I can say this is more sustainable, or you can say, I don't know, maybe, even the second one is sustainable. But, a lot of times what happens is if you use a recycled materials, you assume that, it is sustainable. But I have many, many case studies where I have shown that recycled materials, if they are available close to the project site, then they are sustainable. But if they are available at a long distance, that require a lot of transportation, then it's better off using, nearby virgin materials rather than recycled materials. So where they are available, where are these recycled materials available, related to the project site. So, if you have close to the site, then, it becomes sustainable. But if you have to transport them, then these environmental emissions associated with the transportation are going to be so high that it's better off using, virgin materials. So, as you know, in this time, cutting any carbon emissions is extremely important. So if you are hauling long distance, the amount of greenhouse gases that you're going to generate, that's not good compared to the benefits that you are going to get by using the recycled materials. So the idea is, which one is more sustainable, and how do we do that? So this project is, just the suburbs of Chicago. It's a highway I-90. Stands for interstate. It's a reconstruction project. It's a 14-mile stretch. They reconstructed. This is how the highway looks. So this kind of a location, if you are familiar with this, you would have if you are from the local area, you would have known exactly where it is. So then, if you have a project site here, you should know, okay, where are the raw materials and, coming from. So all the materials that are needed for this, where are they coming from? Because in sustainability assessment, we really need to know what materials we need, where are they available, how are we going to transport those to the project site. So these are going to control your sustainability. And then, as I said, again, transport distances. You need to know those from the raw material vendors to the maybe, if you are mixing concrete, someplace, or you're doing on-site, you need to know where the distances are. So the payment design alternatives, those three options, as I mentioned, payment design design procedures are very well established, and we teach our students these methods. So in this one, basically, this is the cross section of that 14-mile highway that was reconstructed. And it has the concrete pavement, as you see here, the 13-inch concrete, and then they have a 3-inch subbase asphalt, and then there's a 9 inches of this recycled subbase. I said subgrade, but it's actually subbase. And so they reuse the recycled aggregate right from the same location. And the design life of this pavement is 50 years. So this is not a subgrade recycled, it's a recycled aggregate, 9 inches. So this, as I said, this is how they reconstructed the pavement. And is this sustainable? This is the question that we are asking. And then, as compared to the other alternatives that could be possible. Here, everything is exactly the same, this cross section, except, okay, instead of using the recycled aggregate, if I use the, subbase virgin aggregate, what would be the difference, right? So that's what, that's the difference. Sorry, this is not a subgrade, but it's a subbase. So in this case, what would have happened is, if I was not going to use this recycled aggregate, then all the concrete that is removed, that had to be loaded up in trucks and sent it to landfills, and then we have to bring in virgin aggregate from wherever it is available, and to the project site and use it. And even this also has a design life of 50 years. Now we thought about this third alternative. Instead of concrete pavement, can we use the asphalt pavement? So this is the asphalt pavement design you have here. And asphalt pavement is not going to last long. So you have a 20-year design life, and then it needs maintenance periodically. Maybe you can extend up to 50-year life. And the design of these asphalt pavements, is established very well. So we use the ASTO and IDOT. IDOT stands for Illinois Department of Transportation design manuals for designing these things. So the design is well established. So in this one, compared to the previous cases, we want to use the recycled aggregate, and then we want to use this asphalt pavement. So we're trying to compare these, three alternatives. So the technical design is, where we followed this ASTO and IDA design guidelines. And obviously, wherever you are, whatever the agency you are working for, you need to follow their, design guidance. So in our case, we don't have any expansive soils here, which is good. I know in some parts of the world, even some parts of the U.S., we have expansive soils. You have to, uh, take special precautions, or incorporate special design features. And the materials that we got is non-erodible base material, and we don't have big environmental issues, typical Illinois issues. Good drainage is available, and traffic assumptions or this one. So all this go into, this is all the design input for designing these pavements. And this is the pavement design methodology. I'm going to just these are the things that you can assign students as homework, and they can come up with these thicknesses based on this. So basically, the idea is we have these three payment design options, right? So alternative one, basically that's what has built, as constructed, and we are comparing, the sustainability of that versus sustainability of these two other options. So you need to know what are, when you are looking at sustainability, you need to really know how these are going to be built, right? So the constructed section, that the first one, as I mentioned. So you're going to, take out the asphalt pavement, you take out the concrete pavement, you crush the concrete pavement, and then, proof roll the existing subgrade soil, and spreading and compacting reused pavement, paving asphalt base course, and paving the concrete base pavement. It's a typical construction, but the only thing is, so in the beginning, you have an existing pavement, right? So you need to take out the asphalt and the concrete, and then prepare it to have the new pavement. And the crushing of this concrete results in the recycled aggregate. Right at the site, they crush it, and they store the recycled aggregate, and then they reuse it when they are building the new pavement. So in the number two option, basically we are not using the recycled aggregate. That means all the asphalt and all the concrete that you took out from the old pavement, that has to be taken out to a disposal facility, and then you have a clear ground. You can proof roll and construct the new pavement based on that. In the alternative three, kind of, again, we are going to reuse that crushed concrete as a aggregate. So you have on-site operations to utilize this concrete and stockpile at the site, and then you have the ground preparation, and then asphalt pavement construction. So we know exactly how a contractor would build these pavements. Now, the real question is, which one is sustainable? Okay. So I've been working on developing sustainability frameworks, and based on the triple bottom line approach. So that when you talk about sustainability, we are talking about this triple bottom line in a functional manner. So you need to look at broader environmental impacts, broader economic impacts, broader social impacts. Of course, when we design it, in our design courses or in our research, we make sure that the technical aspects are satisfied. So, payment is going to perform. All the three alternatives that we looked at it, they're going to perform well, they're going to carry the traffic. But in doing that one, what are these triple bottom line impacts? What are the broader environmental impacts, broader economic impacts, broader social impacts? So you might have seen this one, but when it comes to the sustainability quantification, we really need to define what are these indicators. So what are the environmental indicators? What are the economic indicators? What are the social indicators? So we really need to define those things. For example, environmental indicator, you want to have a low carbon footprint, so that greenhouse gases, or carbon footprint is the indicator. So that's the only one indicator, right? And similarly, you could have other, environmental, indicators, eutrophication, those kind of things, and those could serve as indicators. And economic, you need to know what is the direct cost, indirect costs, those things. And the social is how people, are going to be affected. And nearby people, all kinds of stakeholders, whoever is going to be affected by the project, how are they going to be affected, positive way or negative way. So this is the most challenging part, is to define indicators. And we don't want to just use anything that comes to our mind as an indicator, because the requirement for indicator is that it should be represented by a numerical value. So, for example, when I say greenhouse gases, CO2 equivalent can represent that metric. So, likewise, anything we define as an indicator, that should be represented by the metrics. And if you have metrics, but there should be a way to calculate that metrics. For example, for carbon footprint, you have CO2 equivalent, that's a metric. And then we have a lot of carbon footprint analyzers that can be used to calculate the carbon footprint. And so that's kind of a tool, right? Carbon footprint analyzer is a tool. But that's the simplest assessment, but that people make, carbon footprint analysis for different things. You must have seen carbon footprint analysis done for different projects. But we are going beyond that. Carbon footprint is not only, it's important, but just the one part of this overall sustainability indicators. So we need to have multiple, environmental indicators, and multiple but relevant to the project. And we need to have multiple economic indicators, multiple social indicators. So when you have this bunch of indicators with numerical values, how do you come up with some kind of a conclusion? So that's where we need multi-criteria decision analysis tools, where we can use all these indicators and with their metrics, and come up with some kind of a rational justification for whatever we are saying. So again, the sustainability is all about triple bottom line framework. So the environmental, typically, I'm just showing as examples. So look, environmental indicators. It could be greenhouse gases, air pollution, energy used. A lot of people look at energy and greenhouse gases, carbon footprint. And we need to look at water usage, natural resources, waste generation, biodiversity. So these are all kind of typical indicators that you can consider for environmental. And economic, these direct costs are, we know very well how to calculate these things. And then indirect costs are the ones that, we are not aware of in the past, but now it's becoming very, very important to consider. What is the social cost of carbon? What is the cost of these environmental pollutions? What are the benefits, like employment, that this project could provide? So all kinds of things that you need to consider. So we have to go beyond our direct cost estimates into these options, looking at these things. And then social aspects, how people, right, an individual or a community going to be affected. That's the most important thing to look at it. And you know that's not easy. uh, you know the environmental aspects, for example, greenhouse gases, we can quantify it, but when we have to deal with how a person is going to be affected by the project, how the community is going to be affected by the project, we don't learn that one in our any of our courses. So that becomes a little bit very challenging part, but you know that is an important component. Now you're talking about equity, justice, environmental justice, social justice. A lot of things are happening uh, for sustainable development, and you cannot ignore the social aspects. So now, all aspects, environmental, economic, and social aspects are given same equal weightage in sustainability assessments. The other thing that one should consider is life cycle thinking. As a civil engineers, and we don't teach our students these things. We we do a lot of design. We teach a lot of design courses, and we basically assume that materials are going to come to the site, and we're going to build it, and then we're going to use it. So that's kind of level that we go. But in terms of sustainability, we need to have this life cycle thinking. What are the raw materials that are needed from mining, right? And then those materials will go to transported to the manufacturing facilities. For example, it could be concrete, or it could be cement, or it could be steel. And those materials will be transported to your construction site, and then we are going to use all the construction equipment to construct that one. And then we're going to look at use and maintenance. And then you need to look at it, at the end of that project, what are we going to use with all the materials that we're going to generate? Are we going to recycle or dispose? What are we going to do it, right? So right at the beginning of the project, we should be looking at all of these things. And all these at each of these life cycle stages, you're going to have some environmental impacts, economic impacts, and societal impacts. So we need to account for all of them, and then when you combine all of them together, then it becomes the overall project, whether it's sustainable or not. um, so that's the preferred way of doing the sustainability. So not just looking at just the on-site construction, but you need to look at what materials you're using, what it takes to make those materials, what are the emissions, um, and also societal impacts. You know, we can talk about these things a lot, um, but that's the essence of it. So you have your technical design in the sustainability assessment. You have this technical design, and then you have, in our case, in this project, we have three alternatives. All three alternatives could be used. So I want to do the sustainability assessment, do the economic, environmental, social, and then I want to do integrated assessment, because these would be, you will not see all of the indicators to be favorable for one option. So it's, decision is easy to make, but sometimes environmental aspects are good for one case, but economic aspects are bad, or social aspects are bad. So we cannot say just based on the environmental aspects this is more sustainable. So we really need to consider all the three pillars of sustainability equally, and then make the final decision. So we need to look at the environmental sustainability. That means, we need to be able to calculate those environmental indicators using some tools. So for environmental sustainability, the most common tool that we use is life cycle assessment. Um, and for economic sustainability, you want to do the life cycle cost assessment. And then for social sustainability, we don't have much developed for this assessment, but I will show you an example of a tool called the Social Sustainability Evaluation Matrix that I developed in 2014. And I'll show you that as an option to use for social sustainability. And then how do we do the integrated sustainability? As I mentioned, we need to use some multi-criteria decision analysis to combine these environmental, economic, and social indicators and come up with the overall sustainability index, maybe. So what I want to show you is how did we do these things for these projects. So um, follow this as an example, and this methodology can be applied for any other projects that you have. So as I said, environmental sustainability assessment, we use the life cycle assessment. And if you have a tool specific tool that is developed for your application, you can use that one. But if you don't have it, then the LCA would be a general methodology, and that considers all the life cycle stages that are involved in your project. And this tool is really good because you can calculate the impacts, environmental impacts, indicators and metrics. If you have multiple options, you can compare those multiple options at the same time. And then this is not like your finite element or finite difference software or numerical modeling. It's basically you have a data, and then basically looking at taking the relevant data and analyzing the data. So you have these softwares that are available that have extensive databases, and there are different assessment methods that can be used. So instead of using manually, we can use these programs, and then get all the information about the materials, their environmental impacts, and then we can do the analysis. So life cycle assessment is a very standardized method. So everybody uses ISO 14040 method, so which is good. So before ISO standard, people had their own ways of doing LCA, so that created a lot of confusion. But now if you don't do LCA according to the ISO method, it's not going to be accepted. So in LCA, as I mentioned, you have these different life cycle stages. For each life cycle stage, what are the raw materials you need? What is the energy you need? Okay, so you specify that one, and within this programs, for example, SEMA Pro or Gabby, there are different LCA softwares, and that they will have information for given materials, what would be the environmental outputs. So you basically we are you get the products whatever we want, but for environmental assessment, we are looking at these environmental outputs. So this ISO standard basically it's very, very structured, and you really need to follow this structure. First you define the goal and scope, and then you need to create a inventory of the materials and energy sources, and as I said, databases are used to get all the impacts, and then you do this life cycle impact assessment, and then you have the interpretation of the results. So as you see, my arrows, they are back and forth. They are not like a linear process. You define the goal and scope, and then go into inventory, and then say, oh, I don't have the data that I need to be able to do accurate assessment. Then you go back and redefine your goal to be more realistic with the data that you have. So every stage, every phase, you have back and forth, and so it's a iterative process, not just a linear process. So that's I can talk about the LCA all day, and I teach LCA for our students in my graduate class. But how do we apply this LCA coming back to our project? Remember, our roadway project is a 14 miles, but you don't have to do the assessment for 14 miles. So basically, we call it a functional unit. So let's say I'm going to the road width is 12 feet, and then let me do the assessment for 1 mile. So you don't have to do for 14 miles. So 1 mile, if I do it, and all the impacts that I calculate for 1 mile, If I have 14 mile, I multiply by 14. If I if I have 100 miles, I multiply by 100 miles. So that's the definition of functional unit. You do for selected unit, and that will allow you to extrapolate or calculate for whatever the actual distance that you have. So in this case, what I'm trying to do is 12 feet is the standard width of our highways. And then I'm going to do all the calculations for 1 mile. And then you need to look at, as I told you, that life cycle, right? From raw material acquisition all the way to the disposal. If you are doing, a comprehensive study, you need to consider all the life cycle stages. If you are not considering it, then you really need to specify, what life cycle stages you are considering, and make sure that the reader or whoever is evaluating your results, is fully aware of that. Because sometimes, ideally, I want to use all, entire life cycle stage, but I don't have data. So if I don't have the data to include all the life cycle stages, you are better off not doing than assuming some wrong data and doing it. So in this case, we consider the raw material acquisition, transport of the raw materials, and manufacturing of production of concrete and asphalt, and transporting those materials to the site, and actual construction, and then maintenance and demolition and disposal. So all the life cycle stages have been considered. So this is really is the much preferred option. So then you think about, okay, what are the field operations, right? So as I said, this is an existing pavement. So you're going to break up that pavement, and then you crush it, and then you're going to create this recycled aggregate. And asphalt, you need to take this one out. I mean, if you are disposing off-site, then you load it in the trucks and take it out. If you are reusing, then you crush it and store it at the site, and then preparing the subgrade and compaction, placement of the concrete or asphalt, and then leveling. So this is a typical construction thing. But you need to know these things, because in the sustainability assessment during the construction phase, we really need to input what equipment that we're going to be using and how long we're going to use. So knowing how much is the fuel consumption rate is, we're going to see how much of the gas or petrol is going to be used up during the construction, because that use of that petrol or gasoline creates the greenhouse gases. So we are trying to account for all the environmental impacts during the all life cycle stages of the project. So basically, you need to consider all the equipment that is going to be used, each stage, each life cycle stage, how many hours we're going to use it, and how many gallons of gasoline we're going to use it. And then also, the materials are going to be transported, right? Transported to the site or from the site. You need to know, how much material that you're going to transport and what is the distance. So the weight is tons, and then distance is miles. So we multiply those things. It's called ton mile. That's the input that you need to provide in this kind of analysis. So we did this one, for alternative one, right? So we have equipment fuel consumption, all the materials that we used, and the material transport in terms of ton miles. So this, aggregate, preparation, and then paving, and then maintenance and demolition. So you can see these life cycle stages, what equipment is going to be used, how many hours are going to be used, what is the gas consumption rate, so total gas consumption. So all this information. So you need to, put it in this, for a sustainability assessment, you need all that. So same thing for alternative 2, right? So, in alternative 2, when you are taking out the pavement, you're taking out the asphalt and concrete and dumping it out, right? I mean, you're not reusing it in alternative 2. You have these dump trucks, they need to go to a landfill, that requires a lot of use of these dump trucks, and paving, maintenance, and demo, and same thing for alternative 3. So, so this kind of information is needed for sustainability assessment. Okay. So we are looking at the life cycle stages. We are looking at all the equipment and all the materials that are going to be used. This is the comparison of how much fuel consumption is for three alternatives. For aggregate disposal or preparation at the site, paving, maintenance, and demolition. So obviously you can see the maintenance, asphalt pavement. The third one is the asphalt pavement that requires more maintenance. So that's why you have more. So again, so you need to, this is the LCA inventory. You need to, for alternative 1, alternative 2, alternative 3, what are the quantities of the materials that you're going to be needing. And these quantities have to be input not only for environmental purposes, but also for cost estimate also, right? So you need to, so I will show you the cost economic assessment later, but these materials have to be input into environmental assessment also. So when you put all that information into LCA, like a software like SIMO Pro, you're going to generate the results like this. So what we have here, I want to explain one figure, results for one alternatives, and you will see the similar results for other ones. So what we are looking at here is, this is the environment from life cycle assessment. These are the environmental indicators that you're getting. So the global warming that you see here, so that's the carbon footprint. Actually, you can get all the numbers, but this is showed in a normalized way, and which one is contributing to the total. It's kind of so this ozone depletion, this is smog, this is eutrophication, this is the acidification, carcinogens, non-carcinogens. So you have all these different indicators, right? So, what are the elements that are involved in making this one, and which one is contributing how much, right? So for global warming, the paving material is contributing. In all these cases, the paving material is making huge difference compared to, talking about equipment that you're using, what is the fuel consumption of. So those are making some difference, but not as much. But the majority of the impacts are coming from the paving material. So that's why doing the research on pavement materials and making sure that we use the sustainable materials is very critical. So then you can actually, in LCA, you can look at, okay, I'm getting this paving material, and which paving material is giving me, impacts in this one. So you can look at, detailed information about, what specific components of your system is contributing. So here, asphalt is contributing to 59.5%. And the truck used for transporting the materials is causing 16.8. Concrete for paving is causing 14.9%. So you can, by doing this analysis, not only you will know, what is the, let's say, what are the impacts, but which ones are causing more impact. These kind of analysis are good because, okay, if I want to reduce the environmental impacts, what should I do? Then you focus on the ones which are contributing more environmental impacts, right? You don't want to focus on something that is contributing less. So you cannot really change the situation that much. So you need to focus on aspects that are really contributing more, and then maybe you can look at alternatives to address that one. Maybe okay, one material is contributing more, so maybe I should use something else that has a less impact. So this is for design alternative 2. You can see again, paving material is causing a lot of problems, and the transportation is impacting ozone depletion and also the maintenance materials, maintenance part of the materials used for maintenance. Again, asphalt is causing some problems. Truck transportation, concrete, and design. Alternative 3, again, you can see the contributions of all the components in that payment alternative, see where the impacts are coming from. But that's all, like looking into the details about each individual alternative. But now our goal was to look at these three alternatives and look at which one is more sustainable. So looking at those results and normalizing with the highest values, you get these results like this. So these are all the environmental impacts that I mentioned that you get from LCA. So here you see this. These are all the indicators, and normalized with the highest value. This alternative three, is having the highest impact. For example, global warming, it has the highest impact. Compared to that one, the alternative one and two has a less impact. So clearly you can see from here, alternative three is a bad choice because it has a higher environmental impacts in all indicators that you can look at it in this one. And this alternative one and two, they are comparable. There's not much difference. Uh, you know, but some of them is higher, some of them are low. Global warming, for example, alternative two, in this case alternative two, some cases alternative one is higher. So because the only difference between one and two was whether you use the recycled aggregate or virgin aggregate, um, as compared to the so this and the third one includes the recycled aggregate, but it uses the asphalt. So asphalt causes a lot of problems. So now economic indicators. So you need to calculate this costs for each of these alternatives. So during the year zero, you have initial construction costs, and then you look at the maintenance. So you need to look at the entire life cycle and what it takes to construct. So these are the asphalt um, uh, pavement, that alternative three, that needs a lot of payments, a lot of maintenance. But whereas concrete needs less maintenance. So those information is given here. So you need to know how often you need the maintenance, what is involved in the maintenance, and those things also have to be accounted in the economic assessment, also in the environmental assessment. So here we're calculating all the costs for all the quantities for each activity, and we look at the standard costs tables, and then we calculate what would be the cost. So generally we use the construction cost index, um, typical numbers, and then we calculate it. And if you calculate that one, alternative one is coming out to be $2.66 million. And then alternative two is coming up with $2.63 million, and alternative three is $1.8 million. And this is just showing the graphically, the construction costs, maintenance costs, and demolition costs. So total cost is this, and the cost wise, the asphalt payment is coming out to be cheaper. So if you strictly look at the cost, asphalt is better, but from environmental point of view, when you looked at it, that was really the worst case, right? So you really need to think about, what do you really want to do, at the end to be sustainable. So you need to also look at the indirect costs, right? Monetize the environmental costs. So for example, greenhouse gas. So, the social cost of carbon, this US EPA came up with this number of $42 per ton. You already know the amount of greenhouse gases generated for each alternative, and you multiply that one. This is the cost, of fixing the problems due to greenhouse gases. That's what let me put it easy way. So this is the direct cost, but because you are emitting the greenhouse gases, there's going to be costs associated with that one. So you add them together, so you're going to get cost here. So the cost of carbon here is less, cost of carbon is here less, but cost of carbon here is very high. And then if you look at if you include the cost of carbon, the costs of all of them are comparable. So it's just if you ignore the environmental costs, then asphalt comes out to be the cheapest option, but it emits a lot of environmental emissions. So if you monetize the cost for that environmental emissions, then they're all coming out to be the same. So not only carbon, but you can also monetize other environmental impacts, eutrophication, acidification, smog, and all the environmental impacts can be monetized. So what it means is, so if I have the impact of, if I have this much of acidification, and how much damage it's going to cause, not only the harm to public health, but also to the environment. And there are studies that have looked at these environmental impacts and the costs associated with that one. So the tools for this one, yeah, actually LCA tool has LCA SIMA Pro as a methodology where you can convert all the environmental impacts into monetized costs, and you can look at those things. So here, alternative 1, alternative 2, and alternative 3. Alternative 3, that is asphalt payment, has huge monetized costs, environmental costs. So we looked at the environmental, we looked at the economical, and let's look at the social. So this is becoming important, and this is the one civil engineers are not familiar with. We don't even talk about these issues in any of our classes, but it's becoming extremely important now. You look at the literature on sustainability, the social justice, so equality is becoming very important, because the infrastructure, there's a lot of discrimination of where infrastructure is being built, and also the environmental impacts, who is really being impacted by these environmental issues. So there's a lot of disparity, a lot of discrimination in terms of all these things. So people are now, emphasizing the social justice, social impacts. So we need to consider whether it's a small project or big project, whatever it is, we need to consider the impacts of that one to people who are going to be affected by that project. So how do we quantify? How do we define these social aspects? How do we define this one? So it's a very challenging aspect. So I developed a tool called Social Sustainability Evaluation Tool, and basically it has these 4 dimensions. How an individual is going to be affected, how a community is going to be affected, how a community's economic situation is going to be affected, how the community's environmental situation is going to be affected. So you can define those dimensions, and under each dimensions, you can address the key areas or key issues depending upon the specific project. For example, this project, so these are the 4 dimensions, as I mentioned, and the key theme indicators were developed based on this specific project, specific location, identifying the stakeholders around that area. For example, individually, okay, as an individual, how the individual is going to be affected, effect on quality of life issues during and post construction. So what troubles that an individual is going to face during the construction, and driving quality, what is the quality of driving that he will have or she will have, with different pavements. So basically what I'm trying to say is, you need to have a hard look at, or you may need to get help from social scientists to come up with these key theme indicators. Okay, once we get these key theme indicators for individual, community, economic, and environmental, how do we quantify those things? So to quantify this, you identify what the stakeholders, public, roadway agencies, and then how you need to get the feedback of these people on your key theme areas. So, comfort of the road, what do you think it's going to be? So you do surveys and interviews and workshops. And then what we do is, we generally create a Google survey or interviews or questionnaire, and we go to the affected people, and then we ask them to give the rating. For example, 0 is no impact, +1 is positive, +2 is negative, -1 is negative, -2 is negative. So for each of these key areas, we ask that question, and we say, for if we have this concrete pavement with recycled aggregate, alternative 1, alternative 2, alternative 3, we ask them to rate these things. So we get all that feedback. Now, that the questions answers, we use convert into numerical terms with 0 plus 1 plus 2 minus 1 minus 2, and then we have this response. For this project, we did a survey, and then we got the responses, and when we add them up, these are the results in a table form, but these are in the graphical form. The first one is the first alternative, second alternative, third alternative. So social individual. The second one was found to be bad, community wise and economic wise and social and environmental point of view. And in the grand score, what if you add all of them, grand score, higher the score, better it is. So alternative one is conceived to be the better option based on all these social indicators, and the second one seemed to be less. And whereas the third one, you can see, the second choice. Basically, you're asking people, right? Whenever you say you're using the recycled materials, people get excited about it, and that's, I think, is reflected in this high scores. Whereas when you say I'm going to use the virgin material, then the scores are less. So this is how you can capture, but there is a lot of room for coming up with the new tools to assess the social sustainability. So if you're interested, please pursue that. And then, okay, we have environmental, economic, and social. Then how do we integrate those things? So that's where we need to do the integrated sustainability assessment. So we have all the indicators, environmental, economic, and social indicators. And there is a way to normalize those values, or you can apply some weightages depending upon the importance of each indicator. And then you have a criteria, you can have a requirement, and then following this approach, you finally get a sustainability index. So we have all the environmental indicators, economic indicators, and social indicators. Combining all of them, we are getting this social sustainability index at the end. So in this process, we have to use the multi-criteria decision analysis, analytical hierarchy process. But I have this publication, if you are interested in, look at this one, where we explain in detail and also give you some other examples of how this integrated sustainability assessment can be preferred. We call that tool is called QUALIX, Quantitative Assessment of Life Cycle Sustainability. And you can get this paper and read it. And if you have a hard time getting that one, just send me email. I will be happy to send it by email. Okay, we applied this integrated framework, and we looked at environmental, economic, and social, and we calculated the sustainability index. So giving the equal importance for environmental, economic, and social, you can see that alternative one is the best choice. Of course, the higher the sustainability index, better it is. The first one is the first choice, and the alternative two is the second choice, and alternative three is the third choice. But if you look at environmental point of view, this first one and second one was better, and the third one was scoring very low, so you cannot even see it. From economic point of view, you can see this, and social point of view this. And in economic point of view, not only direct costs, indirect costs are reflected in this one, and the social aspects are this one. So you have conflicting results for each of these dimensions, but when you integrate all of them, you can make a sense of overall results. So this is how finally you can make a decision. Okay, alternative one is a better choice. And all these things can be done before you actually construct the project. In this case, we constructed one alternative, and we are evaluating is that sustainable or not. And luckily, our assessment shows that it is sustainable. But if you have doing a new project where you haven't constructed anything, maybe you can rationally do this analysis and recommend the one which is sustainable. Now, how much importance you want to give: environmental, economic, social, right? So this could this could change the results. So you can apply these weightages. If I even if I take 60% social, what people prefer, still this the trends are the same. So the sustainability index values are different, but alternative one is better, and the second choice is this, third choice is that. Even if, let's say, I don't care about environmental, I don't care about social, what I care about is how much it's going to cost me, right? So if I apply that kind of a criteria, still I'm getting the same conclusion. So I always prefer doing this kind of sensitivity analysis to look at can we get a different conclusion if I vary these weightages? In this case, consistently, alternative 1 is a better choice, alternative 2 is the second choice, and alternative 3 is the third choice. So from environmental perspectives, alternative 1 is better. Economic perspective, alternative 3 is the best from direct cost point of view, and social point of view, alternative 1 is better. So looking at the integrated approach, alternative 1 has the highest sustainability index. So I hope I demonstrated how you can do a sustainability assessment for a project. Although I applied to this roadway project, but it can be applied to any project that you're working on, and it has alternatives to look at it. So this is kind of a very general sustainability framework that you can apply anywhere. So just in closing, I want to just mention that, please think about doing this life cycle sustainability assessment to, select the most sustainable design. And LCA is the best tool to quantify environmental sustainability, but economic and social sustainability methods are not well established, but do the best that you can, right? Because it's important to consider the sustainability. But one factor is this sustainability is becoming more and more important. Carbon footprint is becoming more and more important. So now we don't have codes and regulations that require considering the sustainability in our designs. But I'm sure in the near future we're going to have those requirements. Actually, in the U.S. Is actually started some projects require sustainability professionals on the staff, on the design staff, to design the project. So they would not give you a project unless you demonstrate that you have designers who can consider the sustainability, or looking at their track record on how they address the sustainability on the projects that they have done in the past. So no matter what, I would say it's our moral responsibility to do the right project and do it right, because the sustainability and climate change is everybody's responsibility to address. Also, you might have heard a lot of talks, how important is the sustainability, and the climate change and all those things. So I have heard, hundreds of presentations, if not thousands, and I get sick of hearing those presentations because, well, yeah, I know sustainability important. I know, climate change is important, but what should I do? Tell me, what should I do? So that's what I mean. Let's get into the action, not just talk about it. I think, whatever the project you are doing, look at the end through the lens of sustainability and see if you could do something different. And actually, what is happening is, because of the consideration of sustainability and climate impacts, now we are developing very innovative solutions, kind of nature-based solutions. And we are creating some innovative alternatives to conventional solutions. So that's really good thing that's coming out of doing these assessments. So if you are interested in learning more about sustainability, or I recommend you to teach a course on sustainability to your students. Use this as the textbook, or if you are new to sustainability world, take this book and read it. It's very easy to read it, and get all the background that is needed. It talks about why sustainability is important, why climate resiliency is important, all the different tools that you could be using, what are the best management practices that you can have towards the sustainability. And then there are some example projects presented in this one. So I use this one as a textbook for my graduate course. I teach sustainable engineering class. So I recommend everyone to teach, sustainable engineering class. Just an announcement before I end my presentation. I organize a weekly webinar series on geoenvironmental engineering, polluted land, waste management, and sustainability and resiliency. So we have 3 more webinars until the end of this year. But past webinars have been recorded if you go to this website, you will find like almost 50 webinars that have been recorded on different topics. I have a couple of sustainability related topics there. Just the one that I gave recently is there. So if you want to know a little bit more about sustainability and resiliency frameworks, I recommend you to go to this website. And from that website, you can go to the YouTube channel, and the YouTube channel, you can subscribe it, and you can have all the videos to watch. It's a free subscription. There is no payment for anything. And whenever you have a free time, I recommend you to watch those videos. So this is my contact information. Please feel to contact me anytime. Um, and these are my lab web addresses, and you can go to my lab websites, and you will see a lot of my publications and other information is posted there. And if you are interested in teaching sustainable engineering, there's a link there on it that shows the syllabus and things that you need to get started to teach a course. So with that one, Dr. Prasad, I am done with my presentation. I will be happy to take any questions if there is some time, or I'm always available to answer the questions through email.
Yes, sir. Thank you very much, sir, for your nice presentation and good lecture. Actually, it is very, very important as a civil engineer uh, for this sustainability assessment. And here you have covered environmental, economical, social integrity aspects. And basically, when we are going to design the roads, this optimum road pavement design among the three, that is from the joint concrete pavement with recycled aggregate only as the subbase, or joint concrete pavement with virgin subbase, or the full depth asphalt pavement with recycled aggregate as a subbase. You have taken these three and you have nicely explained the all the three, and what are the results with respect to LCA also you have shown, sir. And I hope it is very useful for the those who are working in this area. And life cycle thinking and integrated assessment also you have explained, and these are very helpful to the researchers, those who are working in this area, and particularly environmental assessment and the phases of life cycle assessment. All these are very nicely explained, sir. I hope it is very useful, and particularly social sustainability importance when we are going to see and how this is important, because we are teaching so many things in the class, but we are not covering this social sustainability importance. So that also, as from now onwards, we will try to include in our syllabus or in our teachings. Consider these things, sir. And I hope sustainability design will set an importance, and maybe these regulations also maybe come in, maybe coming in near future, sir. And sir, one question I have, sir, because for using this recycled aggregate, RAILM has given some specifications, sir. Other than that, any other codal provisions or specifications are available for utilizing this recycled aggregate, sir?
Yeah, there's a lot of information available. ACI has it, so you can look at the literature. I don't know, that's in India, it may be different, but here it's pretty common. So, you can do the literature review and then find out, ACI, in the US, it's pretty much, very
Okay.
standard.
Yes, sir. Yes,
So
yeah.
even the local agencies have specifications for, you know, uh, on what, the materials for using that. So yeah, it's and the contractors are also very familiar um, with crushing and sieving and making sure that specifications are met.
Okay, sir. Okay, thank you, sir. And I hope this, I am also attending this web series, sir. And I am requesting all the participants also, please, sir has shown one website. So you go through it. It is just like our code book, I can say. All the information related to the environmental and sustainability aspects, you already 50 are recorded, like that sir is giving the information. So we can download that from the website, and we can utilize that for your studies and all that. And any queries, please you can comment on the box, or you may ask sir. Otherwise, sir, if they have any queries, definitely they will contact you in your given email ID, sir. I hope.
Yeah.
Thank you, sir. Thank you for joining with us, and it is a very
Yeah.
great
Thanks,
opportunity.
everyone. Yeah. I know
Yes,
you every day you are hearing like three
Prasad?
lectures, long lectures. Yeah.
yes, sir.
Go
Manohar,
ahead, Manor. Manor.
Yes, sir. Yes, sir. Just same question with you, Prasad. So, sir, in LCA method, life cycle assessment method, there is a number of criteria is considered, like in terms of economics, then social environment integrity. Sir, is there any proper criteria or fixed guidelines to assess that properties? In terms of
Ah,
social, economic.
yeah. That's what I was saying. Like, the LCA method is a very standardized method, and a lot of people use it. So, um, that's you have specified methodology and guidance on that one. But on the economics, you have to look at the life cycle cost estimate, like a cost benefit analysis. So those are the things that civil engineers are not familiar with, but we need to get into those things. And the social sustainability is like a hard one, and the things are not developed yet. But uh, on economic aspects and social aspects, I think it's good to get some help from people who are good in economics and social sciences.
Okay, sir.
And there are some tools are being developed now, as we speak. LCA is a standard, and we have a software also, SimoPro type thing. But for economic assessment, we have direct costs that we can do it, but indirect costs and other things, there are tools being developed now. And you know because everybody realizes that civil engineers are not economists or social scientists, so they are trying to develop the tools that can be useful for civil engineers with whatever knowledge that they have. So they're trying to make the life easy for civil engineers, but they want civil engineers to use it because the infrastructure is such a big field, and it can contribute significantly to the sustainable development goals. If you really want to do something, you know make a huge impact, right? So the civil infrastructure really can make the difference. If you are looking at small things, yeah, it's not going to make overall, but civil infrastructure is there all over the world, and it's going to grow, right? With the increased population and aged infrastructure. So you will see, in the US, as I told you, that with the new infrastructure bill, we're going to have new bridges, new roadways, new airports, all these things. There's like a lot of work is going to be done in the next few years. So all those things, if we do the same way as we did in the past, they are not sustainable. So we
Okay.
really need to, going forward, we need to think about what materials we want to use it, how we want to, incorporate sustainability is very important. And because of the scale of the projects, right? So you can make huge difference. So
Yes.
yeah, especially for the carbon footprint. Now they're looking at, zero carbon, net zero,
yes,
because that's becoming very important to consider.
Okay.
yes,
Thank you,
yes,
sir.
sir.
Yeah.
Yes,
Prasad, one more question, sir.
yes, please.
Just because you are the expert of geo-environmental, you have written very nice books, popular book actually, geo-environmental. Sir, in our India or in our Northeast, there is a number of landfill is there. So those are generally not engineered landfill, like a dump. but now the increase of population and urbanizations development surrounding the dam is occupied by some surrounding is a population,
Hmm.
newly construction also. So people are thinking try to stop the dam or maybe some rehabilitations. Is so. Is there any sir suggestions from your side how to solidify it or how can we reuse or engineering make as a engineering landfill?
So that's a big problem, not only in your area, but throughout India, right? I mean,
Yes,
they
sir.
say they call it landfills, but they're not landfills. They're all dumps, right?
Yes, sir.
So
Yes.
they don't have liner system, they don't have gas collection system, they don't have
Yeah.
leachate collection system. It's like, we used to have, in the US, several decades ago, and we learned from that kind of practices and caused the contamination of the soil and groundwater. Some of the sites are still being remediated even after so many years. So in the US, we don't have any dumps. I mean, we whatever dumps we had to close them. We had to put a cap on them and then put a maybe some kind of slurry walls or something to make sure that leachate is not spreading into the groundwater and gases are collected. So and then we all new landfills or engineered landfills and very well maintained, and there's a huge data that shows that everything that we are doing now is protecting the environment and public. So in India is a very complicated situation. I mean, like, even
Yes.
you hear the stories about dump sites in Delhi, right? So I think my approach to that problem is that you need to do something about what is the new waste that is being generated, first of all, right? So what are we going to do the waste? I mean, like, if you keep dumping the waste, you cannot solve the problem. This problem is going to grow and grow. So, I think we need to figure out, I call it like we need to have an integrated strategy. One solution does not fit everywhere. So the rural communities will need something and, cities need something else. So you need to look at all the options, so recycling, biodegradation, thermal, as well as, landfilling options. Um, then the existing dump sites, depending upon the site, you may able to clean it up, take out all the waste from there, or do the landfill mining, or if you have that dump site in Delhi, it's so huge that you cannot really do anything with that one. Our best option would be capping it, and then converting it as a nice park. But the problem is, people are not thinking along the same lines. I think all the stakeholders are not in the same room and talking to each other. Somebody will say that, oh, we want to, create a incinerator, and no, they don't call it incinerator, waste to energy plant, and we're going to make all the waste disappear. That's not going to be possible. And somebody's saying they're going to do the mining and make everything disappear. That's not possible. I mean, these people are not realistic. So I have a presentation I made. If you go to that YouTube channel, there's a presentation I made recently for a short course on landfills at IIT Bhubaneswar, and I posted that recording. If you go to this YouTube channel, that link I posted in the chat box, please
Okay.
look at that one. There are 2 or 3 videos on the lectures that I gave there, and one of them is after closure of the landfills, and what do you use the closed landfills. But unfortunately, people are moving close to these landfills and building the new subdivisions and other things. That's a really sad situation, because people living around the dump sites in Delhi, right? They all have huge health issues, not just the one generation after generation. They are, kids are being born with diseases. It's so shameful, but yeah, it needs we have I mean, it's not a rocket science. You have to look at what has been done other places and what can be done the place where you are at. But I think seems like people are thinking differently. Different people are thinking differently and not coming to the consensus one strategy what to do. And taking the garbage from one location and putting somewhere else, clean areas, you're spreading the contamination to too many places, and that creates more problems. They're taking out the waste from the dump site and putting outskirts somewhere in the clean areas. You're contaminating the clean areas, so that's really bad. So there's a big issue there, and I'll be happy to help you anything that you can do locally. Look at your issue, where the waste is going, what are they doing. First of all, how do we reduce the waste that requires disposal, and then what can be done in terms of the disposal. I will be happy to help you.
Okay, sir. Thank you, sir. I will take sometimes I will contact to you.
Sure.
Regarding these methods.
Sure.
Okay. Thank you, sir. Thank you. Yes.
Thank you, sir. Once again, thank you from this FDP coordinator side from NIT Silchar. And we hope we will meet you offline also in near future. Thank you, sir.
Yeah.
Thank you for your.
Yeah. Thank you. Thank you very much. And thanks, everyone. And keep learning.
Yes, sir.
Bye, everyone.
Bye. Thank you, sir.
Yeah. Thanks.
Thank you.
And one small announcement. Tomorrow from morning 10:30 to 12:30, we have a session. That is Professor M. Amarnath Reddy from IIT Kharagpur. He is going to give his lecture. Sir is from transportation engineering. So those who are related to transportation engineering, they may have get benefited from the lecture. Then after that, afternoon 14 to 16 hours, that is Dr. Manohar Hussain sir from NIT Silchar. He is going to present chemical stabilization of problematic soils. So whether after Amarnath Reddy sir or Manohar Hussain sir time, based on the time, we may have a discussion of this. Just I will take feedback of some of the participants in between if we get time. And finally, in the evening, 16:30 to 18:30, Miss Nadia Andavarapu, she is going to present a topic, innovation in formwork and usage of aluminum formwork. She is from industry, from Chennai. She is going to present his topic. So these three are the tomorrow programs. Thank you all for joining. Have a good day. Good night.
Thank you, sir.
Thank you all. Thank you, Prasad. Thank you.
Thank you. And regarding the examination, no need to worry. We will share a Google link. Amit Kumar, please.
Okay, sir. Okay, sir.
Right. So we will share a Google form. Just you fill it in online. No need of worrying about the timings. You can, wherever you get time, at that time. I will share it in the mail. So you go through it and go for the answering it. Right? And
Thank you, sir.
Thank you all. Thank you.
Okay. Thank you.
Thank you, Hussain sir.
Yes. Thank you, Prasad. Thank you.
Thank you, sir. Thank you.
Okay.